Alright, these are going to be your notes for section 3.1. We're on page 171. We're going to start with constant rate of change, which you can see is at the top here. That's our topic for this entire lesson. And we're also going to learn that constant rate of change is also known as slope, but we'll learn more of that later. So starting here, Marcus can download 2 songs from the internet each minute. So it is 2 songs in 1 minute. And it's shown in this table below. So we have our time in minutes, and then we have our number of songs. So there's something that I want you to recognize, that they're labeling X and Y. And that's actually going to represent what you can also see in the graph at the bottom with a coordinate plane. Y is the axis that goes up and down. X goes side to side. And that should really be more of a review than anything. But I wanted to make sure we know that. So number 1 says compare the change in the number of songs, Y, to the change in time, X. What is the rate of change? So rate of change is what we are looking for. If you look at the time, each time we go from 0 to 1, that's a plus 1. And then if we go from 1 to 2, that's a plus 1. 2 to 3, same. 3 to 4, plus 1. So all of those are the same. Those are all constant. Now if you look at number of songs, we go from 0 to 2 by adding 2. 2 to 4, 4 to 6, 6 to 8. All of those are constant. So when we want to find rate of change, which is like a vocabulary word for this, and off to the side I also want you to put this, and I'll come back to this in just a minute. Rate of change. And we represent this with Y over X. So super important to remember that. So if we compare the change in number of songs, Y, to the change in time, X. We're always doing Y and then X. So number of songs is increasing. Songs are increasing by 2. How often are they going up? Increasing by 2. And time is increasing by 1. So our constant rate of change, we could say it's 2 songs per 1 minute. We could also, if you look back over here at the equation I gave, Y over X, you could say that the rate of change, and this is what you're going to do in some of your work today, is 2 over 1. So we're going to graph the ordered pairs. And hopefully this is also a review that ordered pairs look like this. X comma Y. So we know X comes first, Y comes second. So the first ordered pair that I'm going to use comes from right here. And I can write it as 0, 0. And that one is super special. We call it the origin. Maybe we should label our axes first. So if we're looking at label our axes is the plural for axis. Our X, which is side to side, right here, our horizontal, has to match what our table says is X, which in this case is time. Fill that one in. And then our Y is number of songs. And you can abbreviate number of songs, that's fine. So we have the first one. The next one is 1, 2. That means on the x-axis I start at 0, 0, I go over 1, up 2. Next one I have is 2, 4. So I go over 2, up 4. Next is 3, 6. Over 3, up 6. Next and last is 4, 8. So you go over 4, up 8. So this is what your graph should look like. Notice that it's pretty much going up steadily. Okay, so that's the pattern really. It's going steady, and we could also say that it is making a straight line. Which straight lines are going to be so super important to us in this section. Alright, if you need to pause at any time or go back, you can rewind, all that kind of good stuff. So it shouldn't be a a big problem. 172 is next page. Scroll to the top here. Linear relationships. Read through this definition. It says relationships that have straight line graphs. Go ahead and circle that one for me. Straight line graphs. Like the one on the previous page, they are called linear relationships. Notice that as the number of songs increases by 2, the time in minutes increases by 1. So linear means straight. Write yourself an extra note on the side. Linear means straight. So if you automatically see a graph and it has a line that goes up and down, while that may look like straight lines all throughout, it is not constant. It's not consistently going up like it should be. So if you see a straight line like this, that is straight. That is a straight line. Not a straight line. Not linear. Not linear. These two both are because they're both straight lines. Okay. And then the rate of change between any 2 points in a linear relationship is the same as constant. That means it has a constant rate of change. So when you do have a linear equation or a linear relationship, that means that this line is going to be straight and it's going to have a constant rate of change. So if we could look at example 1, the balance in an account after several transactions is shown. Is the relationship between the balance and the number of transactions linear? So that's what the question is asking you. So if you were to answer this, you would say something like, so restate it, the transaction is linear or is not linear, depending on what we find, because then we're going to find our evidence and everything like that. So if we look here, we have number of transactions. When you see a graph, sorry, it's not a graph, it's a table, it looks like this. We have X and then Y. So X is always coming first when you're drawing a table. So if you have a table that goes side to side like this, X and then Y. If you have a table that goes up and down like this, X and then Y. That's just the rule. Alright, so number of transactions, we go 3, 6, 9, 12. The balance goes 170, 140, 110, 80. So they've already marked it on here, which is really nice. We need to go from 3 to 6, which is plus 3, 6 to 9 plus 3, 9 to 12 plus 3. So those are all the same on this side. Looking good so far. Now on this other side, every time we move, we're actually going down, which means you're subtracting 30. So to find constant rate of change, so constant rate of change, CROC. Great acronym, CROC. Constant rate of change. You do Y. I guess really we should be more specific. You do the change. You should write this on the side. In Y over the change in X. What does that mean? Well, we know Y changed each time by negative 30. That's our Y on top. We know that X changed each time by a positive 3. So if you want to simplify, which you should, negative 30 divided by 3 gives me negative 10. What does that actually mean? That means that right here it's minus $10 per transaction. So each transaction involved a $10 withdrawal. Because when you're taking money out, that's a withdrawal. You're losing money. Or spending it on whatever you're doing it. Look at A. So we're gonna try and do these problems to find out, figuring out if they're linear. Okay? So we can do that. Start with this chart. If I go from 5 to 10, I have to add 5. 10 to 15 plus 5, 15 to 20 plus 5. Not too bad. Now, when I come to this other side, I have 95 to 90. So that I know is a minus 5. And then if I go 90 to 86, I'm subtracting 4. 86 to 82, subtracting 4. So here's where things go wrong. Constant, good to go. Not constant, not good to go. So on the explanation, you could say that the temperature between 95 and 90 is 5 and 90 and 86 is 4. So it's we're just going to label this as not linear because it does not have a constant rate of change. Alright, let's look right here at B, which is a graph. One super easy way to tell if it's a linear relationship, especially if you have a ruler, is to draw a line through the points. If it's a straight line, it's linear. Let's say you don't have a ruler and you're really not even sure, then you can take y over x, which is how we find the CROC, or the constant rate of change. So y over x is going to be 80 for this first one, and look at right here. So 80 is my y, looks like 8 is my x. And I know that 80 divided by 8 gives me 10. This next one, right here, or wait, maybe if you just put it into a graph. Or, sorry, not a graph, a table, that's what I'm talking about. So this first one is my x's are on top here, y. So I have 8, 80, and then right here this looks like 16, and 60. Keep it going, and I have 40 for my y's, 24 there. Okay, so that should be able to do it. If I do like the skip counting, I know this is plus 8. I know that this is plus 8. Okay? From getting to 80 to 60, I have to subtract 20, and I have to subtract 20 here. So since these are the same up top, these are the same up bottom, it is linear. And I can actually find the CROC, or the constant rate of change, by taking the y, which is the negative 20, over my x, the change in x, which is 8. So negative 20 over 8, we can simplify to, what do you say, we divide them both by 4, negative 5 over 2. We can leave it like that, that's fine. We could divide it out, get a negative 2.5, either way. Next page. Remember, you can always slow this down, you can rewind, whatever you need to do here. Alright, let's go through these examples, because we're actually going to be looking at proportional linear relationships. And I'm going to skip the math mumble jumble, don't worry about it. I'm going to actually just show you, that's way easier. So it says 2, use the table to determine if there is a proportional linear relationship. So that's actually 2 different things. You have, is it proportional? And is it linear? We know how to figure out if it's linear, so let's start there. So they've already done this for us. 0 to 5, plus 5, plus 5, plus 5, plus 5, plus 9, plus 9, plus 9, plus 9. So it's constant. The constant rate of change, or the CROC, goes from, you take the change in y over the change in x. So we have 9 over 5 as our constant rate of change, or our CROC. I kind of like using CROC. I think it's funny. All right, so it is linear. Linear. Check. Is it proportional? Proportional. That's our next check we need to do. So to determine if 2 scales are proportional, express the relationship between the degrees for several columns as a ratio. Or a ratio, hopefully you know, just means to divide. So take y divided by x. So this one right here, 41 divided by 5, they got from right here. 41 divided by 5 is 8.2. 50 divided by 10 is right here, 5. 59 divided by 15, 3.9. Since the ratios are not the same, the relationships between degrees Fahrenheit and degrees Celsius is not proportional. So this is not proportional, but it is linear. So if we were to graph these, which are done right here, it's a straight line. And we also know that it is not proportional because it's not going through our super special origin spot. That's another easy way to tell if it's proportional or not.